This is 9.4 real numbers. This is not a real difficult lesson, but it's one that a lot of kids miss on tests. It's the questions from it. For some reason, there's a little confusion on what irrationals and rationals are. We're going to look at the differences in those today. But it's not a real hard lesson. So just try to understand what the meaning of rational and the meaning of irrational is. And once you get that, I think everything else is pretty simple. So let's look at what an irrational number is. It's a number that is it's a number that does not have a terminating or repeating decimal. A number that cannot be written as a fraction, a quotient of two integers. Notice whenever we do our FTE sheets, you have a lot of fractions on there, and decimals that terminate, meaning they stop, and decimals that repeat. All of those can be written as fractions. So all of those are considered rational numbers. Numbers that cannot be written as fractions are irrational. So if we think about numbers like pi, 3.14159.265, and it just keeps going, and it doesn't repeat, and it doesn't end, that's irrational. A number like e, whenever you tackle that number, that's irrational. Something you may hear of a lot, the golden ratio, that is irrational. There's a lot of irrational numbers, and mainly you get irrational numbers from taking the square roots of numbers that aren't perfect squares. Okay, so let's look at the family of reals. We have, basically, I like to think of this, I grew up on a farm, as one big farm, and you have a couple of, you have different cows on this farm, but they're all cows. Think of all the real numbers, they're all cows. And we may have Angus and Hereford and Limousin and Brahma or something like that, but they're all cows, okay? So in this farm, in this pen, we have the irrationals that are nothing like any of these. They are totally separate, okay? But they are a real number. They're considered real numbers. There are numbers that aren't considered real numbers. You'll get into that in Algebra 2. Over here, you have the whole numbers. That's 0, 1, 2, 3, 4, basically counting numbers including 0. You have integers. The whole numbers are part of the integers, but they're not all of the integers because the integers include the negatives of those whole numbers. Of course, 0 can't be negative, but it includes the negatives like -1, -2, -3. So the whole numbers are integers, but an integer isn't necessarily a whole number. Okay, it can be, but it's not necessarily, because a -1 would not be a whole number. Now, these two are rational numbers. You can write integers as a fraction. Okay, so both of these are rational numbers, but some of the rational numbers are not integers or whole numbers. So there are some numbers that are just specifically rational and not either integer or whole number, like 3/4. 3/4 a rational number, certainly not an integer, certainly not a whole number, but it's a real number. All of these are real numbers, but there is this great divide that separates the irrationals from the rationals. Okay, and we're going to look at the differences there. So our first slide, we're going to tell whether the number is rational or irrational. Okay, these first few are very simple. Again, if I can write it in fraction form, meaning I have an integer on top, that's a negative or positive whole number, and an integer on bottom, it's rational. It's totally rational. Okay, so 2/3, it's definitely rational. It's a 0.6 repeating. All repeating decimals are rational. So we're going to write that with a sideways R for some reason. I don't know why I did that. So 5/8, again, you are writing it as a quotient of integers, 5/8. That's definitely rational. That's much better R. 5/6, definitely rational. Okay, remember that's 0.83 of the 3 repeating. A repeating decimal is definitely a rational number. Now, square root of 19, 19 is not a perfect square. And if you put that in your calculator, you get one crazy decimal. Now, the calculator has to stop, but this decimal would keep on going. So this would be an irrational number because there's no way you can write this as a fraction. You cannot write a decimal that doesn't repeat or doesn't end as a fraction. The square root of 6, again, 6 is not a perfect square. If you were to put that in your calculator, you get some crazy decimal. This is definitely irrational. Okay? Now here, this may look irrational because it has a square root sign, but if you look at what's inside, the square root of 16 is 4, the square root of 25 is 5. When you take the square roots of these, the square root sign goes away. So now we have a nice fraction, a nice rational number. It's a quotient of two integers. So this one's definitely rational. So if we can simplify it and get it down to a rational number, it's rational. Okay? Square root of 100, again, that's a perfect square. Okay, if it were 101, it would be different. But this is a perfect square, which is 10, and that's definitely a rational number. So hopefully you see the difference here. This is what's missed a lot, the difference between irrational and rational. Okay, if I can write it as a fraction, if it has a terminating or repeating decimal, definitely rational. Irrational, crazy decimals. They keep going, they don't stop, they don't repeat. They're the square roots of numbers that do not have, that are not perfect squares. Okay, let's move to the next slide. Copy and complete the statement using greater than, less than, or equal to. So we're going to get our old trusty calculator out. So for the first one, you have the square root of 7, and I get like 2.65 if I round it, 2.65. Okay, 8/3, well that's 2, that goes into it 2 times, and that's a 2/3 remainder. 2/3 is 0.6 repeating. So this is 0.67 if I round it. So this one is definitely bigger, just by a little bit, than this one. So when you're doing these and you have your calculator and you're figuring it out, maybe go to 2 decimal places just to check it out. Okay, let's do this one. -3/2, it's -1.5 in decimal form. Square root of 2, if you don't know that, you should, that's square root of 8. You get a second. We should get 1.4, and that's probably going to be enough here. So, and it's -1.4. Okay, now without the negative, obviously this one's larger. But with the negative, this one's closer to 0. So you have to put the sign this way. Okay, again, this one's bigger because it's closer to 0 on the negative side. -4.2, that's good. Now with this one, what you have to do is take the square root first, then multiply it by -3. So once you evaluate the square root of 2, which is 1.414, you multiply by -3, and you get -4.24. Now, which one's closer? This is 4.20, this is 4.24, and they're negative. Which one's closer to 0? This one is. So we're going to put the sign that way. Okay. Now, we did this a second ago. This is 1.414. I'll just do 1.41. 9 divided by 5, well, that is 1 and 4/5, and 4/5 is 0.8. 0.8. So these are both positive. Sign's definitely going this way. 15/4, that is 3 and 3/4, which is 3.75, right? Now, square root of 15, we may need to figure that out. We get 3.87, 3.87. They're both positive, so this one has to be the biggest one. Okay? Again, put them in decimal form. The main thing you got to remember is when you have something like this, where you have an integer multiplied to a square root, take the square root first, okay? Then multiply whatever you get to -3, and that's how you evaluate that. Okay? I think we've got one more slide and we're done. So we're going to order these least to greatest. First thing we're going to do is put them in decimal form. So square root of 10. We get 3.16. I like going a couple of decimal places. You may not have to. Okay, 3 into 7 goes 2 with 1/3 remaining, and that's 3 repeating. 1/3 is 3 repeating, so 2.33. And square root of 2 is 1.414. If you don't know that, you can take the square root of 2, multiply it by 2. You get 2.83. 2.83. So now we can order least to greatest. We have 2.33. We have 2.83. We have 2.9. And we have 3.16. Okay, pretty simple. Put them all in decimal form. We have -2.8. That's already in decimal form. This one we know, we should know, 3 goes into 4 one time with 1 remainder. That's 1.3 repeating, so 1.33. Square root of 3, that's probably a good one to know, and I think I still know it. I'm just going to make sure. 1.73. I was close. I knew it was 1.7. I couldn't remember. 1.73. This is -2.8. We already know that. Negative. Now we got to do the square root of 5 first. So we're square root of 5. And I get 2.24 negative. 2.24. Now we can order these. Okay, first we're going to look at the negatives. The smallest one is the one furthest away from 0. That's -2.8. Then we have -2.24. Then I have 1.33. And the last one, 1.73. Okay? Last problem. This one's already in decimal form. Square root of 22 should get 4.69. Again, if you're unsure on how to do square roots, just make sure your answers are matching mine while we're doing these. Make sure you're doing the square root right in your calculator. Okay, negative 4.69. 3 goes into 16 5 times with a third remainder. That's going to be 3 repeating. And then we have square root of 2, 1.414. We're going to multiply that by negative 3, and we get negative 4.24. Now, these are all negative, so the biggest one is the smallest one without the negative, okay? So with the negative, this one's smallest because it's furthest away from 0. Then we have negative 4.69. Then we have negative 4.6. And then we have negative 4.24. And that sums up real numbers.